All right, let's talk about something that's quietly running the internet behind the scenes, software-defined networking, or SDN. Now, don't worry, this isn't going to be some dry textbook lecture. We're going to break this down like we're trying to build the ultimate lag-free gaming setup. Let's jump right in.
Seriously, have you ever wondered about this? You know that feeling when you're at work or school and the Wi-Fi is just acting weird and it seems to take the IT department forever to fix it? Well, there's a really good reason for that, and it all goes back to the old clunky way we used to build networks.
So yeah, let's start with what I like to call the dumb muscle problem. See, in a traditional network, every single piece of equipment has a lot of muscle, but it has no idea what the rest of the body is doing. To really get it, let's use an analogy.
Think about it like this. Every switch, every router, it's like a traffic cop stuck in one intersection. They can see the cars coming and going right in front of them, but they have absolutely no clue that there's a 5-car pileup 3 blocks away. As you can imagine, well, it's a recipe for total gridlock.
And this is where all the pain comes from. Say you're the tech admin for a big school district, and you've got 50 switches to manage. If you want to make one simple change, like say blocking a new social media app, you would literally have to log into all 50 of those devices one by one and type in the exact same commands. It's insanely slow, it's tedious, and if you make one little typo on switch number 42, you've just created a huge problem. It's a nightmare.
Now, to really understand this, you got to know that every network device has 2 parts. You've got the control plane, that's the brain. It does all the thinking and decides where data needs to go. Then you have the data plane, that's the muscle. It just does the heavy lifting of actually forwarding the packets. And here's the most important part. In the old school way, the brain and the muscle are stuck together, they're fused inside every single box. And that right there, that's the root of the entire problem.
But what if we could perform a kind of network brain surgery? This is where SDN comes in, and it is a deceptively simple idea, but trust me, it's an idea that changes absolutely everything.
This is the big aha moment. This is the question that flipped networking on its head. What if we just took the brain, the control plane, out of every single one of those 50 switches? And what if we put all of that thinking power into one single, centralized, genius brain?
And this image right here, it says it all. This is the before and after. On the left, you've got the old way, chaos, with dozens of little brains all trying to figure things out on their own. And on the right, you have the new way, order. One single mastermind directing a team of very obedient, very strong muscles that just do exactly what they're told.
My absolute favorite way to think about this is like playing a strategy game, like StarCraft or Age of Empires. The old way of networking is like trying to command your army by physically running up to every single soldier and telling them where to go. It's impossible. SDN, on the other hand, is how you actually play the game. You're up in the sky, you have that top-down God mode view where you see the entire map, and you can direct your whole army with just a few clicks.
Okay, so how does this new mastermind system actually work? Well, to get it, we just need to meet the 3 key players in this brand new SDN world.
First up, the most important piece of the puzzle, the SDN Controller. This is you, the player in our video game. This is the centralized software brain that has a complete top-down view of the entire network. It sees everything. It knows the fastest path from point A to point B, and it makes all the strategic decisions.
Next, you've got the switches themselves. In our game, these are your minions, your army. They've had their brains removed, so they don't think for themselves anymore. Their job is super simple. Listen for orders from the controller and execute them as fast as humanly possible. They are pure, unthinking muscle.
And finally, how do the controller and the switches talk to each other? They use something called APIs, or Application Programming Interfaces. Now, don't let the name scare you off. An API is basically just a menu at a restaurant. It's a simple, predefined list of requests that one piece of software can make to another.
And this communication goes in 2 main directions. When the controller talks down to the switches on the ground, that's called a southbound API. Think of it as the player giving direct orders to the army units. You, go here. You, attack that. Then you have the northbound API. That's how you, the administrator, talk down to the controller, giving it the high-level strategy. It's like you're writing the master plan for the player to follow.
Okay, so we've gone through all this trouble to separate the brain from the muscle. So what? Why does this even matter? Well, this new way of doing things unlocks some absolutely incredible, game-changing powers.
You basically get 3 new superpowers. 1, centralized control. You can see and manage your entire network from a single screen. 2, and this is the really cool one, is programmability and automation. And 3, you get just insane flexibility and speed to make changes.
So what does programmability actually mean? It means you can write simple, plain English rules for your network. You could literally tell the controller, hey, from 7 p.m. to 11 p.m., any data coming from my Xbox gets absolute top priority. I don't care if my sister starts streaming 3 4K movies at once, make sure my game doesn't lag, and the controller will automatically make it happen.
Or what about security? This is a huge one. You can program a rule that says, if any device on my network starts acting weird, like it has a virus, instantly cut it off from everything else. That means the controller will tell all the switches to block that device's traffic in milliseconds, long before any human could even pick up the phone to report a problem.
Now look, this isn't just some theory or something that's coming in the future. SDN is already here, and it's the invisible engine running huge parts of the internet you use every single day. And there is no bigger or better example than the company that basically is the internet for a lot of us.
Yep, 100%. Google's entire massive globe-spanning network, the thing that connects all their data centers and delivers YouTube and search and Gmail to billions of people, it is all run by their own custom-built SDN system. It is the secret sauce that makes their whole operation possible. So, when you go to watch that cat video, Google's SDN Controller looks at a live map of the entire internet. It calculates the absolute fastest, most efficient path to get those video packets from their server to your screen. And here's the magic part. If a giant fiber optic cable under the ocean gets accidentally cut by a ship's anchor, which actually happens, the controller knows about it instantly and automatically reroutes all that traffic around the problem. You never even notice a thing. So, here's the big takeaway. By ripping the brain out of the hardware and turning it into smart software, SDN gives us that God mode control over our digital world. The question isn't, how do we manage the network anymore? The question is, what amazing things do we want our network to do? So I'll leave you with this. Now that our networks can think, react, and adapt on their own, what are we going to build next?